James Cook University won the 2012 Green Gown Award for carbon reduction for its integrated approach to energy management on its Townsville campus. As part of the initiatives that we rolled out, we reduced our carbon emissions by 10,600 tonnes per annum. We reduced our energy use by 25% across the campus, our peak demand by 40%, and that resulted in savings of over $2 million per annum.
What was implemented at James Cook University went back to a master plan for the campus development. In 2006, the campus was 70,000 square metres, and we knew by 2015 the campus was going to be upwards of 140,000 square metres. The problem we had was the power supply to the site is constrained. So the outcome and what was implemented was a number of strategies. One strategy was the thermal energy storage system with a centralised district cooling plant attached to the thermal energy storage plant. That enabled us to manipulate the power profiles to the site and also gain demand savings as well as energy savings to the site. Power factor correction was implemented on all switchboards around the site to lift the power factor, and we're currently looking at another demand strategy reduction through the building management control systems and energy management control systems.
The campus had existing about 40 local chillers. These were all being removed and being replaced with the central energy plant, so that we could move the maximum demand that was in the middle of the day for the chillers, move it to the evening when the chiller plant was running. Where you normally have a chiller plant that's 300 kilowatts or so, that you can't really afford to spend too much time tweaking it because you make small gains. But with a plant that's so large, which is typically at the moment about 12 megawatts capacity of cooling, you find that the smallest adjustments we make can make thousands of dollars difference. And over the last couple of years, the central chiller hasn't caused any change at all to the maximum demand, so we have no charge for the chillers, which has taken about 4.5 megawatts off our maximum demand for the campus. The big advantages of having two systems is that we can cross-check, and whereas we use the building management system to change how things run, the energy management system is a better way of reading how the energy is being consumed.
The significant factors contributing to the success ranged from James Cook University's vision and adopting the recommendations back in the early master planning of the infrastructure to the site, but more importantly it was in the ownership taken by James Cook University to continually improve the plant's efficiencies and continually look at how you can make small changes to have a big impact in operating costs to the site. The system currently saves James Cook University over $2 million a year in operating cost savings, but also reduces all the maintenance back to one central location.
Probably the main one I'd say would be the consulting engineer, mechanical engineer, Craig McClintock. He's done an excellent job in the design, and it's proven by the actual functioning of the unit and how well and the efficiency we get.
And James Cook University showed vision in supporting something which was new at the time. There's only a handful of district cooling systems with thermal energy storage components in Australia. And as part of this project, common service corridors were put in place to support the existing buildings and new buildings with communications, power, as well as chill water.
We did have a close working relationship with Ergon on this, because what we're doing essentially is removing 4 megawatts of maximum demand from their grid. And in this, they made an agreement with us from the start that if we would reduce it by what we said we would, they would give us $1 million over 5 years.
We also received a lot of interest from a number of different levels of politics, from federal, state as well as local. We had overseas consortiums from Korea and a number of different utility providers from New Zealand, Australia and all states and other countries. And we had a lot of interest even at a student level, so students from levels engineering, student levels year 1 through to 3, all show an interest in the plant and have regular tours through the plant, and it opens up opportunities for year 4 students to study components of the plant and to try and improve those components for future engineering applications.